Hi, I'm going to walk you through this worksheet really quick. So if we have the secant of negative 195 degrees, we want to make sure that our calculator is in degrees mode. So you click mode, and then you want to make sure that you select degrees and not radians. So we're going to select degrees. And then secant there is no secant button on your calculator, but remember that secant is the same as 1 over the cosine of theta. So we get 1 over cosine of negative 195 degrees. And I can go ahead and just type that in my calculator. 1 over cosine of negative 195 gives me negative 1.035 ... And we're going to round to the nearest 10,000. So tenths, hundredths, thousands, 10,000s. We need one more decimal. 527, which rounds to negative 1.0353. Okay. You guys can go ahead and do this one. Make sure you put this in the radians mode. Okay. Number 3, so we're going to find the exact value of the trig function. We got to make sure, so no decimals. We're going to leave them as fractions. Okay. We're going to find the sine of theta, and theta here is equal to 510. So we're going to find the sine of 510 degrees. Now, I'm not very good at finding the ratios of angles that are outside the initial 360 degrees. So what's a coterminal angle to 510 degrees? It'd be like 510 minus 360 degrees is 150 degrees. I live right by an airport, so yes, sometimes planes fly overhead. Okay, so I get the sine of 510 degrees is the same as this 150 degrees. So I can evaluate the sine of 150 degrees instead. And I know that 150 degrees has a has a reference triangle of 30 degrees. And the side across from 30 is 1/2. We are in the second quadrant, so the ratio is going to be positive since it's above the x-axis. Okay, so I would use your coterminal angles to help you solve. All right, so let's do the tangent of theta. And this time I see that we have a negative angle. So I'm going to be like the tangent of negative 21 pi over 4. And I remember from my even odd function rules that the tangent is, I know that the tangent of negative theta is the same thing as the negative ratio of positive theta, the tangent of positive theta. So I'm going to evaluate the negative tangent of 21 pi, positive 21 pi over 4, because that just seems easier to me. So I'm going to slap on this negative sign at the front after I evaluate. Okay, so again, 21 pi over 4, that is not in our first full rotation, so let's get our coterminal angle. I'm going to be like coterminal. I'm going to do 21 pi over 4 minus 2 pi, which is 21 pi over 4 minus 8 pi over 4. So I'm going to 21 minus 8 is 13. And when I divide 4 into 13 divided by 4 is more than 2, so I'm going to go ahead and subtract another 8, giving me 5 pi over 4. So I am going to now evaluate the negative tangent of 5 pi over 4. These are going to be the same. So 5 pi over 4 is the same thing as negative 21 pi over 4. Okay, next up, I'm going to be like, sorry, this is 5 pi over 4. So I'm going to evaluate right here. Okay, so 5 pi over 4, like that. I have my reference triangle that connects back to the x-axis. My reference triangle is pi over 4 since I have an angle that divides by 4. All angles that divide by 4 have a reference triangle of pi over 4. So I'm going to have sides of root 2 over 2, negative root 2 over 2, and 1. So tangent would be rise over run. So I'm going to take my rise over my run. I can see that is going to come out to negative root 2 over 2, all over negative root 2 over 2, which is positive 1. But I have a problem. I need to bring down the negative sign. So this is going to be negative 1. There are lots of ways to do these problems. You do not have to use the even odd function rule in the beginning. You can go ahead and just solve the problem using your coterminal angles. In fact, we'll do it right now. So tangent of negative 21, ignore this. Okay, so here's another way. Tangent of negative 21 pi over 4. So this time I'm not going to use my even odd function rules. I'm just going to find a coterminal angle. Okay, so negative 21 pi over 4. And since that's negative and I want to get into the first full rotation, positive full rotation, I'm going to add 8 pi over 4, giving me negative 21 plus 8. My brain, make sure this works nicely. Okay, add another 8 pi over 4. They still equal 8 pi over 4. So giving me negative 5 pi over 4. I'm almost there. I'm going to add another 8 pi, giving us 3. So this gives another 8 pi over 4, which is 3 pi over 4. So I'm going to evaluate my angle now at 3 pi over 4, which is in the second quadrant. So my reference triangle here is going to be, connect back to the x-axis, is pi over 4. All right, so I have side lengths of root 2 over 2, negative root 2 over 2, and 1. So I'm going to evaluate the tangent of 3 pi over 4 is the same thing as the tangent of negative 21 pi over 4 because they have the same terminal side. Okay, and that would be my y over my x, my rise over my run. So my y is root 2 over 2 over my x, which is negative root 2 over 2, which gives me negative 1. So that's another way to do the same thing. There's lots of different ways to do these problems. Okay. All right. So number 15, let's do number 16. Okay, so number 16, we want to find the cotangent of theta. So theta is right here, okay? And we actually don't even care what the angle measure is. What we want to find is a ratio. So I want this ratio here, which is ratio of cotangent would be tangent is y over x, so the reciprocal of that would be x over y. Okay, so I need the x length and the y length. So I'm going to go ahead and draw in my reference triangle here. Okay, I can see to get to this point 17, 13, I'm starting in the middle and I'm going to move 17 to the right and negative 13 down. So the x length is equal to 17. The y length is equal to negative 13. How could I find the radius if I needed to? You would use Pythagorean theorem. So 17 squared plus negative 13 squared is equal to r squared. And I'm going to use a calculator. 289 plus 169 is equal to r squared. And then I'm going to square root that answer, but it is irrational. So this is the square root of 458 is equal to r squared. Sorry, is equal to r. So r is equal to the square root of 458. Yeah, okay. Just checking to make sure that 36. Okay. All right. So now that I know my x length, my y length, and my r length, I can go ahead and find any ratio. We want to find the cotangent, which is the x over the y. So this is going to be 17 over negative 13. And that is the cotangent of our angle. Extra, let's find the secant of theta. So of this triangle, basically, secant is 1 over the cosine of theta. So cosine is, again, x over r. So it's going to be flipped. We're going to do r over x. So the r value is the square root of 458, and the x value is 17. That would be the secant of the angle. Okay, last type here. We're going to do, so this one, let's do problem number 21. Okay, so this time we have we have two pieces of information. One is the sine of theta is equal to negative 2 root 5 over 5, and the cosine of the angle is greater than 0. So I'm going to start here, and I'm actually going to start with this cosine theta is greater than 0. And I want you to think about where the cosine ratios are positive. So cosine has to do with the x-axis. So where is the x-axis positive? It's going to be in the first quadrant or the fourth quadrant. Remember, all students take calc. All the trig ratios are positive in the first quadrant, and cosine ratio is positive in the fourth quadrant. Okay, so we can already rule out the second and the third quadrant. Okay, and then I'm going to look, where is the sine ratio negative? Because my ratio here is negative. Okay, so the sine ratio is negative in, well, not in all and not in, the sine ratio has to do with the y-axis. All ratios in the first quadrant are positive. All ratios in the second quadrant, all the sine ratios in the second quadrant are positive. So here in the third and the fourth quadrant, the sine ratios are negative. So I can see that to satisfy both these conditions, I'm going to have to be in the fourth quadrant. Okay, so I'm going to go ahead and draw in a little triangle, a little reference triangle. And remember that the sine ratio is the is the y value over the r value. So I'm going to go ahead and label this in negative 2 root 5, and the r value is going to be equal to 5. So I'm going to use the ratio to be able to build my triangle. Now, how do I find the x value? Well, we're going to use Pythagorean theorem. Okay, so I'm going to use x squared plus y squared is equal to r squared. So x squared plus negative 2 root 5 squared is equal to 5 squared. So I get x squared is equal to, or plus 4 times 5 is equal to 25. And so that's 20. I'm going to subtract 20 here. Okay, so x squared is equal to 5 and a square root. So x is equal to 1 root 5. All right. So what are we supposed to do? We're going to find the 5 other trig ratios. So now, the cosine of theta. Again, we don't really care what the actual value of theta is right now because we know the side length, so we can just figure out our ratios. Okay, so the cosine of theta is x over r, which gives me root 5 over 5. The tangent of theta is equal to y over x, rise over run, so negative 2 root 5 over root 5. That simplifies to give me negative 2. Okay. Cosecant of theta is the reciprocal of sine, so r over y. So my r value is 5, and my y value is negative 2 root 5. Do we like that? Nope. We got to rationalize. So multiply by root 5, giving me 5 root 5 over negative 2 times 5. So 5, and these 5s are going to cancel. So root 5 over negative 2. That is cosecant, excuse me. All right, secant of theta is r over x, which I'm actually going to just reciprocate these two. So 5 over root 5. Again, rationalize. Okay. So I get 5 root 5 over 5. Those cancel, giving me root 5. Okay. And cotangent. Cotangent would be x over y. So you can either reciprocate tangent, or I can just look at my triangle. The x value is root 5, and the y value is negative 2 root 5. The root 5's cancel, giving me 1 over 2. I can see if I had reciprocated this negative 2, I would have gotten negative 1 over 2. All right, if you don't understand this, please come to office hours so I can help you out. Okay, we'll do lots of these problems during office hours. All right, bye.